Hello everyone, does it work? Just making sure. Hey everyone, thanks Fred, and my name is Itiel Shwartz, and I'm the CTO and co-founder of Commodore. And today I'm going to talk about how to prevent Kubernetes from misbehaving. So before we are going to go into the deep dive on how do we prevent it from misbehaving, a little bit about me just to get started. One second. Yeah, so one second. Who am I? I'm the CTO and co-founder of Commodore. My startup is based around helping developers and DevOps to troubleshoot and understand and solve issues in Kubernetes much faster. Overall, I'm a big believer in empowerment and making the whole team much, much better, and not only one or two individuals. In my past, I've done a lot of work both on Kubernetes and incident response. So I feel like all of the talks today are just down my alley. So a bit before we'll go into like how do I prevent Kubernetes from like misbehaving and pitfalls, let me just like clarify that Kubernetes is becoming de facto the standard today in today's like modern infrastructure. We see more and more companies migrating into Kubernetes, and in most conversation I'm having with people nowadays, it's like I want to migrate to Kubernetes. I'm in the middle of the process of migrating to Kubernetes, or I just migrated to Kubernetes. Why the hell did I just do it? So I think that it's clear that like people are doing this transition. On the other hand, it is very clear that people are not that sure what they are getting into, and that's my goal for today. Talking a little bit about possible downfalls and how to avoid them when talking about Kubernetes. I will say that like most of this talk is basically how do I make sure I'm keeping with the best practice standards across my app. And it is true both for Kubernetes and not in Kubernetes environment, like basically every distributed environment. But I will bring like some very good tips and tricks that are specific to Kubernetes. So I will just like point out that Kubernetes is great for a lot of things. It helps us to save money. It gives our developers more productivity. It is easy to do like multi-cluster support, and it has a lot of advantages. But on the other hand, it does bring with it a set of challenges, and we are going to focus today mainly around the challenges when it comes to troubleshooting, or when it comes to making sure that your Kubernetes cluster is continuous, reliable, making sure that your application is always at the highest standards. And I will try to give both the reasoning, like why is it so good, but I will also try to spice things a bit with some personal stories or stories from customers or stories that will help understand why it's so important and what are like the very quick steps that can be taken even today to make sure your application is much more reliable. So I will say the main thing that is very common for people who just migrated to Kubernetes is that it hides a lot of complexity inside of it. And I think that when we see customers that are migrating to Kubernetes, they see Kubernetes as something very homogeneous, like this very nice piece that I can use that will help me to solve all of my problems. But in reality, Kubernetes is a set of a lot of, it is composed out of a lot of smaller and smaller pieces. And basically in Kubernetes, we have a lot of resources that help us to create our environment or to create our application. And when you read the hello world for Kubernetes, it looks very naive and very innocent. And that's what's so cool about Kubernetes. all you need is a simple YAML, and you have your application running in production, which is, to be honest, like amazing. But on the other hand, when you start adding things like replicas and load balancers and ingress and PVC and service and config map and secrets, things become much more complex, and it happens really fast. It happens the minute you have a real full-blown application running on a production level Kubernetes cluster. So what makes Kubernetes incident response so complex? I will say that the first thing is the ability to understand what change in my system. Uh, most issues, most incidents originate from changes or like human-made errors inside the system. This is like on one hand, but on the other hand, because Kubernetes is so complex and because it has so many different pieces that are constantly changing, it is very hard even just to know and to understand what changed as part of my Kubernetes deployment, or how did the system look like 5 minutes or 10 minutes ago. And the fact that you don't even know what was the state of the system before you had an issue makes it 10 times more difficult just to troubleshoot it. Another thing that is very difficult and makes it very, very complex is that today in Kubernetes, in order to gain like full visibility, when you read all of the guides, you are simply installing more and more and more tools in order to make sure that you have everything covered. I will say it is something that is true for like all modern systems, but it is especially true for Kubernetes, because you start with a bare metal Kubernetes, and then you are adding more and more layers, more abstraction layers. You might add things like Itiel, or you might add other like custom resource into your Kubernetes cluster, and each one of those custom resources might have an issue and might cause the problem. And because there are so many different components and so many different tools, you simply don't know where to look at. Even if you have like the full audit logs, it is very hard to know where to focus or where to look at next. And the last thing is like the butterfly effect. And for all of you who don't know it, it is simply the very nice junior developer that just changed that config map, and it just changed like something that shouldn't have caused, like it shouldn't cause anything, like it just changed the number or the variable name, but somewhere the SRE is waking up in like 3 a.m. and everyone is shouting at him because the system is currently down. And because there are so many different connections and so many different layers, it is very hard to know what is the blast radius, what is the impact of a single change, of a poor developer doing an innocent change to the whole system going up in flames. I will say that again, in Kubernetes, it's very easy to do changes, but it's a lot harder to understand their impact. Two more things that are not really technical, but more for culture that makes Kubernetes incident response so hard is the first of all is Kubernetes is still like I won't say it's the new kid on the block, but I will say that there are not a lot of Kubernetes experts. And because of that, what usually happens and what we usually see in Commodore, like I said, our company goal is to make all of this process much simpler, is that inside the company, if you have 20 developers, maybe 2 will know Kubernetes, and those are going to be the bottleneck of the organization. And those 2 are the ones who are going to solve most of the issues. And it's not really scalable. It causes a lot of frustration. And because Kubernetes is so young, we will see this trend like change over time. But at the moment, it is very hard when you have this behemoth, this very complex system that almost no one know really how to handle. The second thing is simply more of like, again, like a cultural change. In some companies, they don't really want to bring their developers with the full set of troubleshooting capabilities, things like viewing logs, going into a machine, and so on. And when you don't bring everyone the capabilities to troubleshoot or like to handle incident in Kubernetes efficiently, what happens is that people simply can't really operate. And then again, there become a silos inside the organization of people who can troubleshoot, who know how to manage incidents, but those are the very small subset of the company, and those ones are simply bombarded with questions and asks. So how do we make, like, I just talk about the complexity and the cultural complexity and the tooling complexity. So what every one of us can do, even today, in order to make sure his cluster is to the highest standards and to solve or at least reduce the number of time the team is spending in managing or responding into issues. I'm going to try and give like a real things that you can do and change even tomorrow. Some of them will be a bit more complex. Some of them might sound trivial, but from my experience, I know that even those small things that sounds trivial for some are very not trivial for others. And I'm going to cover everything from A to C on making sure that Kubernetes cluster is the best it can. So before even diving into the incident response, like what's the best thing we can do? Prevent issues before they happen, and then we don't even need to respond to those kind of issues. So the first thing I think that comes to mind is make sure you have a good YAML hygiene. And that means that your YAMLs are up to the best standards and include metadata. I will try to give like the most common, like two common scenarios. So the first scenario is I'm a developer that is on call. One of the services in my system is misbehaving, meaning it has a lot of 500, the pod is crashing, I'm having a lot of issues. But when I try to get some metadata about who is the owner of this service and who should I call or where should I troubleshoot, I have no idea. Making sure every service has some sort of definition just makes it much easier for the other people to understand and to operate when things are going to hit the fans. And I will say that the other part is much more technical, making sure that you bake in as part of your YAMLs all of the best practices of Kubernetes. Like I will say the most common ones and the thing that I see a lot of companies missing is making sure you configure correctly the liveness probe and the readiness probe. And I'm sure that like maybe like if there is some like experienced DevOps in the crowd, they are like, no, like we are sure that for us, all of our clusters have and all of our services have this liveness and readiness probe. I will say people will be shocked to find out how many services in production lack the right probes or the right configuration. Once you don't have those configuration, what is going to happen is that your system is going to experience problems. The application is going to be not responding or not working as planned. But because you didn't configure the liveliness or readiness probe, what is really going to happen is that from a pod standpoint, everything is going to look okay because your liveness probe is returned to 100 no matter what. So I will say, first of all, configure it, like have this configuration in your YAML. The second thing is spend time trying to really understand what does it mean for this specific service to be ready to get traffic? What does it mean for this service to be up and running? Does it need the database connection? Maybe I need to check a full end-to-end REST flow. There are different answers for different microservices, but making sure you spend the time on it before the issue happens or before you have a problem is critical for making the system much more safe. This is real examples, and I will try to give a short story about each one of those issues, of each one of those tips. And I will say the first one is simply the lack of liveness of liveness probe. When we started Commodore, we are a company that is designed to help people basically, like I said, maintain the highest standards or troubleshoot Kubernetes efficiently. And we ran an analysis on the customer anonymized data just to understand how many customers don't have this liveness probe set up. And we were shocked to understand that for production cluster, around 30% of the customers were missing this very critical probe in their production environment. And when we suggested those fixes to our customers, we saw that their eyes were wide open, and they simply didn't believe that they were lacking those capabilities. And I think that for each company that doesn't have a very strict YAML, base YAML or template mechanism, they are bound to have services that don't really live up to the standard in their production environment, and this will manifest itself the next time the system is going to have any issues. Because when you don't use the built-in tools that Kubernetes brings you, you can't really expect to gain the full benefits of Kubernetes, of self-healing, of monitoring, and of the self-healing part. So make sure that your YAML is up to standard. We released an open source named ValidKube that can help you make sure your YAMLs are up to the best standards. The second thing is, let's say that you do have issues, and like I said, you are going to have issues. It's unavoidable. The second thing is to be able to respond really fast to those issues. And when I'm saying respond fast, I mean the ability to do a change very fast in order to fix the issue or fix the problem. So taking the time and spending it on the CI/CD doesn't sound really like an incident response area. It sounds more of a dev velocity, but it is critical to do those changes when you have a problem. And it is critical before running into the first issues or first problem to make sure you have an exit strategy, making sure that when the system is going to go up in flames, and it is going to go up in flames, you know how to do a fast change in order to resolve the issue or to fix the problem. And I will say that especially early on inside the Kubernetes migration process, making sure you spend the time and energy on building the right CI/CD tools is critical for the success of the incident management. Because if you need to wait an hour before you can push a fix to production, people are going to be more afraid, first of all, to push changes, but incidents are going to be nerve-wracking because everyone will just wait and see if the fix really solved the issue. And the story, a story here, and it is from my earlier days as a developer. We done a lot of work on improving the CI/CD as part of mainly dev velocity, and we saw that as we spend more and more time on the CI/CD part, we reduce the time we spent when troubleshooting issues. And that is because, first of all, everything was faster, so smaller and smaller chunks went into production, and that in turn caused less problems because every small pieces were like deployed and checked individually. But more than that, once issues did occur, we were able to operate them much more efficiently and much faster. So by doing like a complete focus on the boring CI/CD part, we were able to reduce all of the metrics in the incident response area, which is very cool and very neat. The third best practice is logging. I think it becomes more and more like the standard, but make sure you have all of the metadata, both in terms of Kubernetes, such as cluster, namespace, pod, replica, and so on, but also the application relevant metadata. Things like maybe customer or region or other things that are business specific data, and that they are a part of your logging. I will say again, when thinking about incident response, usually most of the heavy lifting, most of the things that you can do in order to really make a change are not part of the incident response. They are prior work that you are doing in order to make sure when an issue does occur, you are all set. And I will say that without those metadata in place, you are simply going to spend a lot of time when you are going to troubleshoot an issue and when you are going to run into a problem. And the story here is half a story, half a good tip on how do you know that you have all of this relevant information. It is very hard to know before an issue or before a problem what are the key metrics that I need in order to solve it efficiently, because there are so many different failure scenarios and there are so many metrics. And the thing I love to do the most is after an incident, when we are doing the postmortem or the retrospective on that issue, one of the first questions need to be what logging I should have done or should have added to make sure I can solve this issue faster next time it happens. And it might be something trivial, such as add customer name to all relevant logs. And it might be something much more specific, such as let's add a login message every time I get a specific failure scenario. But without constantly spending more time on your login infra and your login capabilities, you are simply going to be in the dark, basically. And you can think about proper logging as some sort of flashlight that help you like shine the way or lead the way towards finding the root cause of the issue that you are experiencing. I'm going to skip on the fourth best practices because I see that I'm running out of time. But the five best practice is simply to invest in proper monitoring. And I talk a bit about logging. I think metrics and logs are like bounded together. And again, I think that if you are not going to invest the time in adding those tools, if it's Prometheus or Grafana or Datadog or New Relic, you are simply going to be lost in the dark when an issue occurs. And I think the thing here that there are the things that are quick wins, making sure you monitor the CPU memory, container status, application metrics such as error rate, HTTP status code, latency, and so on. Again, I will say that the interesting thing here, at least for me, is to make sure you keep on iterating over those metrics, because your system is changing, the world is changing, and in such a dynamic world, you must make sure that your system, your monitoring system, has all of this data in place. And I will say that what we try to strive in Commodore is to make sure that each service has a catch-all monitoring page that everyone know that when they have an issue with that specific service can go there and even in a glance to understand what seems like to be the problem and give the first aid of of troubleshooting. We obviously use Commodore internally as well, but we also use like metrics and monitoring tools in combine. I'm going to go into questions, but just to conclude, the biggest secret around incident response, or like improving your incident response, is spending a lot of time when there's no incidents in place. And that means making sure that you have the set of helpful tips and helpful a guidance prior to the incident. So when you're going to have an incident, you can rely on all of those very neat things that you just added in order to solve it faster. So I think making sure that you have the metrics, the logs, the CI/CD, the best practices is simply going to really help you reduce the time that you spend responding to issues without the need to do anything inside the incident response itself. And I think it's a very, very worthwhile investment.